All right, so, well, I'm lost. Really?
No.
Ah, right here. So, after I make something that is a legal move, I need to actually make the move, right? Right now, I'm just yelling legal move. But now when we get to this line right here, we know for a fact that where they have decided they would like to drop the checker, they can drop a checker there and it is a legal move. So now we need to make a move. Okay? So we are going to create a function, private void make move, and make move is going to take a column and a checker. Make sense? It's going to take a column and it's going to take a checker. And it's going to try to drop that checker as far down that column as it possibly can. That makes sense? Okay, so I'm going to walk my column backwards. I'm going to start off at the last row. And I know that one of these columns will in fact have a opening. That make sense? So I'm going to say if the board at row I, column call, is not an instance of checker. Hold on. Okay, so in the column that I'm dropping the checker in, if I look at the very bottom row, if that guy is not an instance of checker, then I can make my move and I'm done. Right? So how do I make my move? I say the board at bucket I call gets the value C. And then I'll break out of the loop. We've talked about break, correct?
Yes.
Okay. And I happen to know that I would not call this method unless I could definitely make a move. Okay? So I will eventually drop a checker in here. But I'm going to try in the last row first, then keep working my way to the top of the board. Okay? So that's what make move does. So after I know I have a legal move, I need to actually make a move. So I say this dot make move. The move is going to be the column, and the checker will be cur player. Because cur player is equal to either a red checker or a black checker, depending whose turn it is, right?
Mm-hmm.
So our players are not actually playing with a pile of checkers. Our players are playing with a checker. And they're creating a pointer to that checker at various places on the board. So it's actually a more efficient version of Connect 4. All the checkers, all the red checkers that are on the board are all the same red checker. Oh, and make move takes a integer as a parameter. So I'm going to say integer dot parse int call. Okay. So we'll make our move. and then we'll switch players. Eventually, I'm going to need to check for a winner, but for right now, we're taking the baby steps, right? So now I should actually have made my move. So let's test this. All right, so let's go column 3. All right, so there's my move. Now let's go column 2. Now let's go column 3. Oh, we're playing. Now let's go column 4. Column 4. Column 5. So let's make sure that the next move says it's an illegal move on 5. Oh, I put in something that was not a number. It was user error. Not a program problem. I meant to hit a 1 and I hit the tilde. All right. Does that make sense? So now we can make moves. I'm sure it's recording here. Yeah.
Yes. You turned it on.
Well, I wanted to make sure it didn't crash.
Oh.
Okay. So we can make a move now. After we make a move, we need to see, is there a winner? Correct? Because if there's a winner now, who won the game? The guy who just made his move. That make sense? All right. So how do I check to see if there's a winner? What are the different ways you can win? Connect 4.
3 vertical column.
4 across in a row? 4 vertical? Or 4 horizontal? Well, how do I check to see if the board itself has a winning move on it?
You can say just whenever, every 4 in a row. Just one question.
Okay, I have to check the entire board.
Yes.
If I always check for a winner after a move was made, do I actually only need to check to see if that move was involved in a winning move?
If you're checking every time it went to 1 5 times ago.
Does that make sense?
Oh, that.
You have to check the verticals every time, okay? And for horizontals, I'm coming 4 times.
Well, no, the point is that I only need to check to see if I won as a result of the move that I just made. I don't need to check the entire board.
No.
Right?
Yes.
Okay. Because if I'm checking after every single move, then if there's a winner now, it's because the move that was just made created a winner. All right, so I need to now make I need to now do my check around the move I just made. So I want to look at that column to see, is there a winner in that column, correct? Then is there a vertical winner in that column? Is there a horizontal winner in that column? And then specifically, is there a diagonal winner in that column related to the checker, the move that was just made? Okay, let's create a method. Go down here. We'll make this guy private. Boolean is winner. And let's take in the column that the move was just made on. How about that? Make sense? All right. Now, let's check for a vertical winner first. That means 4 checkers of the same type in a row in the current column. Does that make sense? All right. I know that there's been at least one move made in that column, correct? Where is that move? How could I pinpoint at what row that move is in? Well,
No.
column tells me the column it's in. The row would be the very first row that is a checker, starting at row 0. Okay? So, I need to first find the row. So we're going to say int row starts off at 0. While the board at bucket row call is not an instance of checker. While that's true, row plus plus. So I'm going to start at row 0. Is that a checker? If not, move forward. Is that a checker? If not, move forward. Is that a checker? Yes. Maybe I just found the checker I just previously dropped in there. Row is now a 2. Let's leave it at that. Break out of this loop. So when this loop is done, row will be equal to the checker that is at the top of the current column. So all other checkers are below that. So to check for a vertical winner, I just need to check the color of the current checker, the checker at the top, and compare it to the 3 beneath it. Make sense? Now, because all of my moves are made with the exact same checker, I'm not creating multiple instances of checker. I'm just putting the same checker pointer all over the place, right? I can actually ask, is the checker at row the same checker that's at row plus 1, the same checker that's at row plus 2, same checker as at row plus 3? Does that make sense? I can ask that question. Now, what if I cannot have a vertical winner unless my row is what? I have 6 rows.
4, that's it. 5, 6, 4, 5, 6.
Well, 4, 5, 6 is just 3. So we need 4 in a row.
I mean, it starts with 0, 1, 2, 3.
Okay?
You know, you can check when you come like 4, 5, 6.
Right, but it's 0 through 5 are my rows.
Okay.
So 5, 4, 3, 2.
Exactly, yeah.
So I cannot have a winner if row is, I cannot have a vertical winner if row is greater than 2. Does that make sense? It has to be 2 or less in order for there to be a vertical winner here. Otherwise, I don't have enough spaces to have a vertical winner. You know, if row is 5, well, you're only going to find one checker there, i.e. not 4 of them. Okay? So, check for winner. If row we'll add the variable in here in a second. So if row is less than or equal to 2, we might have a winner. We have a possibility, right? And the board at bucket row call is equivalent to the board at bucket row plus 1 call and kick it down a line here. The board
4 plus 2.
row call is equivalent to the board at row plus 2 call, and the board row call is equal to the board row plus 3 call. If all of that is true,
It's winner.
turn true. We have a winner. I don't need to check for other kinds of winners. Found a vertical one. Done. Make sense? If any of that's false, no vertical winner. Make sense?
Can we return like winner, winner, chicken dinner or something?
Well, this guy just returns Boolean.
I know.
Just returns true or false. We can decide how to interpret it. We can choose how we'd like to interpret the fact that we have found a winner soon.
The setup.
Okay. So before we go any farther, I'm just going to do a return false here at the end. Let's check for vertical winners. Let's test our code for a vertical winner. Okay, before we go and check for all the other kinds of winners. So I'm going to go back to play. After we make our move, we need to check for a winner. If this dot is winner, integer dot parse int call. Oh, hold on. Let's put return in for right now. That'll end the program. Actually, I'll put break in. That'll get us past the end of the while loop. Have the same thing. Okay, so keep in mind that this will only detect vertical winners right now. So don't go trying to do any other kinds of winners. So let's go and test this. So right now, every single time after I make my move, I will then check to see if there's a winner, passing at the column I just made.
My bad.
Let's see. So we are going to go in column 3, column 2. All right, we should have a winner after this next move.
Winner. How come it still don't show it?
It did. It said winner.
No, I'm talking about the last red.
Red, yeah.
Thank you.
There's your.
Yeah.
Okay, and let's run it one more time.
Should we just tell you after 6 and it's illegal? To try to go up any further.
Oh, well, it does. It just spins back around. But I get it. You want it to eventually scream at you. Say, look,
Hey,
look, look,
at it.
stop, stop, stop. All right. So we're happy with our vertical winners? Okay. Hold on, I'm lost. Oh, here's winner. Okay. Now, don't want to just return false yet, because now we need to check for horizontal winner. Oh, okay. Well, how is there a horizontal winner?
Simple.
Four in a column.
Hmm.
Four in a column.
Okay, well,
I mean,
if there's a horizontal winner, wouldn't it be at the row
yeah. Four.
that we're...
Mhm.
So we're going to find the row the same way we found before, right? So we can just reuse the row variable. Already have it. And what we're looking for is
The column change.
the 4 rows, or I'm sorry, the 4 columns around the current column on the same row. Now, how many do we go out in each direction?
Depends on where you at.
Depends on where you are. Depends on where you at.
Yeah.
So you can like
Depends on where you at.
four equal
Where you at, girl?
3. The same things up, okay. The same what we did before as we know. But change row equal, I mean smaller than or equal 3 plus minus the same but change the row instead of columns.
That's true, but then we're going to have a whole bunch of different versions of checking for a horizontal winner.
I mean if you're going to start from 0.
What if we started at the current position, that's 1, and we counted to the right as many as we have in a row, or until we run out.
Okay.
Then we count to the left as many as we have in a row, or until we run out. And if what we have is at least 4, it shouldn't ever exceed 4 because that means we would have won on the last turn. But if what we have is at least 4, we have a winner. So what we're going to do is we're going to say int count is equal to 1. Definitely have 1 in a row. At column, col, and row, row. There is a checker there. That's the one we just dropped. That's 1 in a row. So we're going to go ahead and count that guy. Now,
Are we assigning?
Yeah, we
it
are.
to one?
so now we need to go and count to the right as many as we can go. So while actually, let's do this. For int I is equal to col plus 1, I is less than the board at row dot length I plus plus. So we'll start off to the thing just to the right of the current row. Here, I can actually run this real quick. So let's just say I made my move right here. Let's just say, well, whatever. Let's say my checker's right here. I'm going to go and start looking right here. And I'm going to keep going this way as long as I find checkers that are the same checker as I currently have. As soon as I find a checker that's not equal to the checker I currently have, I'm going to bail. Don't need it, right? So, if, now I know if I'm in here, I'm looking at a legitimate column. I'm not off the end of it yet. I is a legitimate column. So the board at row, column I, if that guy is equal to the board at row, col, those are the same checker, count plus plus. If they're not, break. Only go to the right as long as I find the same checker. That makes sense? As soon as I find not one in a row, break out. Don't count it. And the loop will naturally make sure I don't check buckets that don't exist. Because it will make sure that my column, I'll start off at column +1. It'll make sure that I don't walk off the end of that particular array. The board at bucket row dot length. So I'll stay within that row. So this is heading to the right. Now we need to do the same thing heading to the left. So here we'll put a little check to the right, check to the left. So this would be column -1. Keep going as long as I is greater than or equal to 0. I minus minus. So this will walk to the left. So if what I'm looking at matches my original checker, the original guy, the guy I made my move at row col, if those guys are equal to each other, increment count. As soon as they're not, break out. When we're done with these 2 for loops, count holds the number of checkers in a row that I found. Right? So if count is greater than or equal to 4, we could just say equal to 4, but greater than or equal to 4, then we will return true. Make sense? All right, so let's test that one. All right, so we'll do 2, 2, 3, 3, 4, 5. Now let's do 1.
And 5.
We have a winner.
Yay.
Make sense? Okay. Well, what about horizontal winners?
Do the same thing.
Yeah, I meant I don't.
You mean diagonal?
I don't mean anything that we've been talking about. Through the process of elimination.
You mean diagonal?
Diagonal winners. What about diagonal winners? We know that my move is at row col. That's where my move was. So if my move is right here and I want to check all the diagonals, I can go up to the right, down to the left, down to the right, up to the left.
Yeah.
So I really need 2 separate counts. I need to do something pretty similar to what I did for horizontal, but I'm not just going 1. I need to check both crosses.
We need 2 for loop.
So now let's do check diagonal. Just for the sake of sanity, I'm gonna create 2 new count variables. Count dcount1 starts off at 1. Dcount2 starts off at 1. All right. So for starters, let's check up and to the right. Check up and right. So in order to check up and right, I'm going to start at row, call. Well, actually, I'm going to start at row minus 1, and call plus 1. Let me run this real quick so you'll see what I mean.
Plus,
I'll start at row minus 1, and
Oh,
call plus 1.
Gotcha.
Row minus 1 plus 1.
You have-
Minus 1 plus 1. That make sense?
Yeah.
Okay.
Have me backwards for me.
Yeah.
What the heck is next?
Let's see, how do I want to... Okay, so for I is equal to row minus 1, I greater than or equal to 0, I minus minus, that'll walk me up the rows, right? And each time I walk up a row, I need to move over a column. So I'm going to say int curcall. It's going to start off at integer dot parseInt call. Plus 1 to move over one column. Oh, call came in as an int to this one, so I don't need to parseInt. Just need to say call. Okay. So first time through, I'll be checking the guy up a row over a call. But I only want to check this if column is not off the end of the current row. I know row is protected. That makes sense? Because this for loop keeps me from going on to an illegal row. So if curcall, because I don't want to break call. I don't want to mess up the variable that was passed in. So if curcall is less than the board at I dot length, that means I am looking at a legal row and column. Correct? So if that's true, and the board at row call is equivalent to the board at I curcall, decount 1 plus plus. Else break. So what does this say? This says make sure I'm looking at a legal row and column, then check the checker that I made my move on, and if it's the same checker as the one at the current row and column, then go for it, right? Decount plus plus. Now, every single time I do that, though, I also need to say curcall plus plus to move to the next column over, knowing that my row is going to increment up. My row is going to always go up. Curcall needs to go over. So I need to do that as a manual increment, because the loop will do it for me for the row. Make sense? All right. So this checks up and to the right. Now I need to check down and to the left and change decount along with that. So I'll steal all this code. Check down and left. Stay consistent. I don't need to redefine Kercall. So this time Kercall will be equal to column minus 1. So I'm going to the left.
Oh,
Okay? And row will start off at row plus 1 and keep going as long as I is less than
but then
the board at bucket row dot length. And we'll add 1 to the row each time. And we'll ask if Kercall is greater than or equal to 0. Because we're moving to the left. So I'm looking at I know I'm looking at a legal row because this loop monitors it. But I need to make sure that Kercall does not walk off the front of the array by subtracting 1 from it each time. Make sense? Because we're going down and to the left. I did it so it looks right to me. So if you were all looking at me heading that way through a mirror, it'd still look backwards. All right. So that checks up to the right, that checks down to the left. Well, we can go ahead and ask a question real quick. If decount is greater or equal to, decount 1 rather, is greater or equal to 4, return true. Okay? Because that means I found 1 on one of the diagonals. I found a winner. Now, if I didn't find a winner there, I still have another diagonal to check. So let's check the other diagonal. So I checked up and to the right. Now let's check up and to the left. So I'm going to steal this code. We're checking the other diagonal. So up and left. So Kercall will go call minus 1. Row will also go minus 1. Kercall greater or equal to 0. Because we're going up and left. And we'll do decount 2 plus plus. And Kercall minus minus. Make sense? Similarly, to check down and right, go plus 1. Kercall is less than the board at row.length, and they're equal to each other. Decount 2 plus plus, Kercall plus plus. Decount 2 greater than or equal to 4. Make sense? All right, let's test this. So let's do, it's always hard. Row. Well, at least we have an error right off the bat. So I had a, oh, that's actually interesting. So I put in a 3. We didn't have a winner in the first 2. We came down here to here. Did I show you the debugger last time?
Mm-hmm.
Okay, I'm gonna go ahead and run that again. So I'll right click, put a breakpoint on. Just gonna get us right here quickly. So I'll hit play. Actually, I'm not gonna hit play like that because we need to hit the little bug dude.
The little beetle.
All right, and I'll put in a 3. Take us into our code. So we're right here. And now where's my, there we go, these guys. So I'll step over that line, we're still good. The row should be
0 minus 1 minus 1.
no, should be 5. Row should start off at 5. 5 minus 1 is 4. Yeah, so row is 5. 5 minus 1 will be 4. All right, so we'll walk through this. Cur call is equal to 4, which is legit. Oh, that's actually interesting. The I think this will fix it, and then you can tell me why. How do I exit out of?
Just hit the Java on the other one.
Oh, yeah, yeah. Okay. Pretty sure this will.
That's what it
Oh, wait. Can't do it. Oh, no, that is not going to fix it. The problem is that we are comparing nulls. So just because they're not both red checkers or not both black checkers, we're counting them if there's multiple nulls in a row. Does that make sense? Because we originally put nothing in there. And when we say where's my is winner? Here, I'll run this again real quick in the debugger. And I think we'll see what I'm talking about. So I'll do 3. All right, so we're checking up and right to the initially. So I'll step into this. Row is 4 here, so row minus 1 is 4. Keep going as long as it's greater than, but cur call is going to be equal to 4. is cur call less than the current guy's length? 7? It is. But is the board at row call, that guy, is he equal to the board at I cur call? Do we have what I is here?
Background call. What?
Okay, cur call is why is it showing me at 6? And I is, let me just step over one more. Okay, so I is 4. And it's saying, are those two guys the same? Is a red checker the same as null? So I is 4 is this guy. Cur call is 4.
Mm-hmm.
So the board at well, this guy is null. Up and right, he's going to be a null value. I'm not able to see a good way of seeing the value in this guy. Can I? So it showed me a bucket 6 there. Okay, I want row at bucket 5. Okay, there we go. So, but row 5, we have a red checker, and we're going up and right. So at row 4, at bucket 4, we have a null. So we're comparing a red checker to a null. That'll be false, right? Red checker, null, not the same pointer. So we'll drop through this real quick. All right, now we're down to here. Cur call starts off at column 2. Cur call's column 2. Board at row. So here's our red checker. Is this guy the same as I, which is 6? Oh, we don't have 6. That's what the problem is. I is currently 6. Keep going as long as... Yeah, it starts off at 6. We don't want to say the board at bucket row dot length. We just want to say the board dot length.
Now it's for which one?
Actually, it's all of them.
Oh.
All of our for loops for our diagonals, we are checking on the rows. And we manually move the column. Rows is governed by the board dot length, not the board at a particular row dot length. So all of these guys that deal with the length.
How many will it be?
The ones that are 0 are fine. So this one also needs to change. So we just need to change 2 of them. We need to change the down and right to just the board dot length, And we need to change the up, or the down and left to the board dot length.
What about the check to the left and check to the right? I mean, yeah.
You mean for horizontal?
Yeah.
The row stays constant on that.
Okay.
So I don't think that should be impacted.
Gotcha.
So let's switch back over here. Okay, so there's our first move. Then we'll do, this requires some strategery. There's my second move. Here's my third move. Gotta be careful you don't accidentally win. There's our winner.
Yeah.
So that's a diagonal up and left. So now we need one up and right to test that. Three, four, four, five, five, four, five, six, 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 six. Okay, so that's up and right, so that works. Now let's do down and right. So let's build up on 3. Okay, 4, 4, 4, 4, 5, 5. Nope, can't do 6. 2, 5, and then 6, 6. So there's my down and right. And now I need to do my down and left. There's my down and left. All right. So, depending on who the winner was, we can say if there was a winner, if Kerr player is equivalent to player 1, then we can print out player 1 wins. Else, player 2 wins. Make sense? So, there's all the code that makes up Connect 4. Lots of crap, right? What was your paper on today? Procedural versus object-oriented programming, right? The benefits of it? There's Maine.
Go back to board.
This is more impressive. All that detail we just wrote. To play our game, we create a board, tell it to play.
How cute.
And then the nightmare is in here. This?
No, there we go. Yes. Now I'm gonna say you.
All right. Questions on any of that?
Maybe after my brain stops hurting.
All right, I'll put this back up in a few minutes. Let me talk about the final project. So you do not have a report due.
Thank you.
We do have a final project. So, again, this is a reminder, do not submit .java files. Either paste your source code in or zip it up into a zip file. Implement a modified version of the card game called War. In this game, there will be 2 players. Each player will be dealt 26 cards. That is half the deck of cards. The players do not get to choose which card they will play. Instead, the top card from each of the hands is played, so a total of 2 cards are played. The card with the higher value wins, giving the player who played it a point. After 26 rounds, the game is over and a winner should be declared based on points. So in the event of a tie between cards, for example, 5 of clubs versus 5 of hearts, the tie will be broken as follows. Diamonds is the weakest suit, followed by clubs, hearts, and spades. So the 5 of spades would beat the 5 of hearts, the clubs, or the diamonds. Okay? So, what you're doing is you're creating all the objects necessary to create the game of a modified game of war, where you should create 2 players. Each player gets dealt 26 cards. So we already have a deck that can shuffle itself, that can deal cards, right? So you're going to create players and hand cards to those players. So each player's hand has 26 cards in it. Now, for this particular game, it's going to be a complete simulation. The human being's not necessarily going to play. What we're going to do is each player will play from the top of their hand. So their hand kind of becomes a mini deck, if you will. A deck of 26 cards. So if you and I are playing war, what I'll do is I'll take the top card out of my hand. You'll take the top card out of yours, we'll lay it down, and we'll decide which of those cards wins. What's the higher value? Okay, if I have the 5 of whatever and you have the 7 of whatever, you win. You'll take those 2 cards, you get a point. That make sense? And at the end of 26 hands, where we're both out of cards, the winner is the person who has more points. That make sense? But in the event of a tie, you have to have the tiebreaker stuff here for diamonds, clubs, hearts, spades, in ascending order in terms of the power of the cards. So if we both lay out 5s, we need to determine who actually gets that point based on the suit of those cards. Does that make sense? Okay, so you already have a lot of pieces of this. You have the deck, you have the card. So really you're building the player and then the logic for the game. This game will not be as difficult as Connect 4 was. Connect 4 algorithmically was harder because of checking for all the different ways of winning. Make sense? All right, questions about that?
Aces are the highest value or
Who?
no? Ace.
Yes, ace is the highest value
Okay.
card. So an ace of any suit beats any king.
Diamonds like come into picture when both are on the same level.
You mean? Are you asking when to do the tiebreaker?
Tiebreaker.
Yeah, when they're both the same value. So if both cards are a 5, or both cards are a 6, or both cards are an ace, you determine who wins based on the tiebreaker rules, based on the suit. Otherwise, the suit doesn't matter. If I'm comparing a 5 to an 8, it doesn't matter what the suits are. An 8 always beats a 5. Make sense? Okay, and let me look at the calendar here. Oh, we decided this was going to be due before Christmas? That's not what we decided? What did we... Oh, then what did we decide?
The last time
You said-
like January 1st.
January
2nd.
2nd.
You said that.
Okay. How about January 3rd? That's the end of the week
Friday.
after the 1st.
Gotcha.
Okay. If you finish it before that, submit it, email me, and I'll grade it ahead of time so I can submit your grade earlier. If some of you would like your grade, from the way I submit grades, it doesn't matter. I can submit one grade at a time. So if you finish it by next week, or you message me this weekend and say, yeah, I'm not going to do it, you just want that to be your dropped grade, then I can submit your grade on Monday. Okay?
If someone don't want to do it,
I'm going to drop your lowest 2 scores.
this one and
This one and one other. Well, any 2. Your lowest 2. Lowest 2 across all the different kinds of assignments. Okay?
This
So-
one 200 points?
No,
or
normal.
100?
Normal assignment. Yeah. So it's not weighted any more than any of the other ones.
depends on the grade for this week of the site.
Okay. The grades for this week I should have done. I'll guarantee it by Monday, because I'm in like grading mode right now. 'Cause I got to get all my grades turned in. This is grading mode. I'm in grading mode.
So Keynote do this.
Yeah, yeah.
before the-
So if you don't see the grades posted by noon on Monday, email me, bug me, because they should be in by then. All right, so I will plan on checking the grades for all of those starting January 3rd, unless I hear from you before that. In which case, it's not going to take me long to grade each assignment, and then I can submit your grade. So just make sure you bug me until I give you what your final grade is. Sound good?
Mhm.
Questions, comments, concerns, bribes?
What the actually I want B plus or A minus. What the average point it should be?
Let's see. A B plus would be around a 90, 91. Yeah, I mean you're basically you're dancing 91, 92, 93. 93 would be an A minus, 91 would be a B plus.
One for 85.
What would be a what?
What the grade for 85?
85 would be a B.
Can you give us your grading scale
I just
one more
did.
time?
Here, I'll write it.
The exact range.
Give me the exact range.
Yeah. Thank you.
It's the same one that Dr. Locklear uses.
Nuh-uh.
No, it's not.
Yeah.
No, it ain't.
All right. So here, and it's the top 2 and lower 2% of each thing. So a 90.
I have Locklear's.
His is 93 to 100. That's an A.
Right. 93 to 100 is an A. So he would have 91, 92 is a B plus.
90 to 92
90 to 92.
is A minus.
That's an A minus.
80 to 89 is a B plus, or 88 to 89 is a B plus.
85.
No.
No. It's B plus.
82 to 87 is a B.
That's so hard.
And that's
Yeah. So 85 is a B. Where did I go?
You were saying 90, 91 was a B plus.
Yeah.
That's an A minus.
Oh. I understand what you're saying.
Yeah.
Yeah, it's the bottom 2% and the top 2% of each range is the plus and the minuses. Let's see here. I'll just finish this. So that means a 80 and 81 is a B minus.
Yeah.
78, 79 is a C plus.
Yeah.
72 to 77
Yeah.
is a C. And 70 to 71 is a C minus. I think you can go from there.
Yeah.
Yeah, it's the same scale Locklear uses. When I put in the percent, it pumps out the letter grade.
Gotcha.
So
And you round up.
Hey, we gotta be precise here.
So once again, are there any bribes? While we're still recording. All right, everybody clear on the scoop.
You never answered Katie's question.
What was her question?
Do you round up?
No, there's no
Those-
rounding. You got to earn your grade.
No, she meant like if it says 0.5, like 82.5. or
Oh
something
yeah,
like
yeah.
It
The
doesn't-
program rounds up. Yeah.
that. To an 83. Okay, gotcha.
So your question is whether it rounds up or truncates.
Yeah.
Yeah.
It rounds up, but I would probably just treat it as truncating, so you get a worse grade.
Of course you would.
How lovely.
It rounds.
What a good.
An 81.5 is an 82. What am I doing? Oh, I got to stop the recording, right?
Yeah.
We good? Anything else you want to have on this recording? Any incriminating?